This is lesson 5 of CS5910. We start by introducing the rationale behind the 3 security principles. They are defense in depth, defense with diversity, and cyber resilience. They attempt to reduce the likelihood of threat realization and to reduce the impact should that threat be realized. They guide the deployment of security control, the development diversified system architecture, operating system, library, and programming language, and the development of survival systems that can perform even under cyber attacks. OWASP, Open Web Application Security Project organizations, define security principles as a collection of desirable system property, behaviors, design, and implementation practice that can reduce the risk. They reduce either the likelihood of the harm occurrence or their impact, since the risk is defined in previous lesson as the probability times the impact. The security designers have found that it is difficult to design all-purpose methods to prevent all kinds of unauthorized acts. Experience of them provide useful design principles and guidelines. They are based on simplicity and restriction. Follow this principle, we can be aware of the threat to our system and ultimately derive a set of protection requirements. The principle of defense in depth is that layer of security mechanism increase the security of the system as a whole. If an attack causing one security mechanism to fail, other mechanisms may still provide the necessary security to protect the system. To defend the network and infrastructure, we need to protect not only the local area network, but also the wide area network from DDoS attack. Provide confidentiality and integrity protection for data transmit over the network to resist passive monitoring. We need to deploy firewall and intrusion detection system to resist active network attacks. For insider attacks, we deploy physical and personal security as the first line of defense, and then deploy authenticated access control and auditing procedure as the second line of defense. Mono-instruction architecture such as Intel 386 or 64 architecture used by current computer systems make it easier for attacker to develop just one malicious software and then attack vulnerability existing in all systems using the same ISA architectures. Systems that dynamically changing instruction set render many malicious software useless, while only incur 40 to 50% performance degradation. We should encourage the development of diverse system architecture, diverse operating system, diversify crucial library such as OpenSSL, and important software package we use. We need to diverse the type of programming language we use in our program. Produce framework that allow real-time, seamless service application migration from one system which failed or about to fail to the others. Cyber resilience is a network security strategy preached by the Defense Advisory Board, January 2014. It adds the hostile and adverse condition as the operating requirement. It requires all systems to performed under the attack. Resilience is the ability of an architecture to support the function necessary for mission success, in spite of those hostile action and adverse conditions. An architecture is more resilient if it can provide this function with higher probability, shorter periods of reduced capability, and across a wide range of scenario, condition, and threat. Resilience may leverage cross-domain or alternative government, commercial, international capabilities. Here is the MITRE Cyber Resilient Engineering Framework. It presents a list of goals, objectives, and techniques for realizing the cyber resilience system. Anticipate, withstand, to deal with the hostile attack, and evolve to adapt to the new hostile degrading system condition. The objectives add new constraints, reconstitute, transform, and re-architecture as objective. New techniques such as coordinated defense, deception, diversity, dynamic positioning, realignment, and unpredictability are added